Welcome to How to Write Recursive Formulas. So a recursive formula generates a sequence by using the previous term, and there are critical aspects when writing a recursive formula. It needs two things: the initial starting term, which we know to be a sub 1, and it also needs the formula for the nth term of the sequence as an expression containing the previous term. So what this is saying is just a pattern based on the previous term. For example, did you add 2 to the previous term to get the next? Did you multiply by 3 from the previous term to get the next? So really important, every time you see the word recursive formula, you're going to remind yourself that you need 2 parts. This is different than the explicit formula. The explicit formula just required one formula, right? Only one piece. And it was good to find any term that you wanted, right? You could find the 100th term really easily. If it asks for the nth term, that's explicit. If it asks you for recursive, know that you need 2 parts. So let's talk about how to actually find the previous term and the next term, because notation is really important for recursive formulas. If you have a sub 1, what comes after 1? 2, right? So the next term is a sub 2. What comes before 1? That would be 0. So you're adding 1 to get to the next term, and you are subtracting 1 to get to the previous term. So a sub 4 plus 1, your next term is 5. A sub 4 minus 1, the previous term is 3. If you have a sub n plus 1 plus another 1, you're going to get the next term is a sub n plus 2. If you subtract it, a sub n plus 1 minus 1, the ones cancel out, and you're left with just a sub n. If you have a sub n, the next term is a sub n plus 1, and the previous term is a sub n minus 1. If you had n plus 6 and you added 1, that would bring you to 7. If you had n plus 6 and you subtracted 1, that would bring you back to 5. And just again, notice how I'm not writing it really large, because right now this is the word and plus 7. That doesn't make sense. Actually, that kind of looks like ant 7. Make sure that your n plus 7, as well as everything else, is an actual subscript. So hopefully we remember that the terms of a sequence can be listed with subscripts, a sub 1, a sub 2, a sub 3, right, for all of the term numbers. So for example, 4, your first term, would be a sub 1. A sub 2, your second term, would be 7. Your third term would be 10, and your fourth term would be 13. So if you're trying to figure out the pattern here, you can see that to get from one to the next, you're adding 3 each time. So this is an arithmetic sequence. So to write the recursive formula, you need 2 parts. Your first part is your starting term, which is a sub 1 is 4. And then your formula is you're taking the previous term. Now, what comes before a sub n? Go back to your thing. We have that what comes before a sub n is a sub n minus 1. This is your previous term. So I'm going to go back and I'm going to write my previous term And then what are we doing to the previous term? We said we're adding 3. So I'm going to add 3. Your subscript should be tiny, a tiny n minus 1, and the plus 3 is a normal size. And both pieces, everything here in the box, is your recursive formula. Let's try another. They want a recursive formula, so we know we need 2 parts. The first part is your first term. In this case, my first term is 2. And then you need a sub n based on the previous term. What are you doing to the previous term? Look at the pattern. You are not adding at all. You're actually multiplying by 2. So if you see here, you are adding by 4, and then you are adding by 8, right? So that's not a common difference. So it's not arithmetic. Instead, it's geometric. So we're multiplying by 2 each time. So if the pattern is times 2, I'm going to multiply the previous term by 2. Now, you can write it like this, but most of the time, you're going to see the multiplication up front as a coefficient. So a sub n is the previous term times 2. Let's try it again. Your first term, in this case, is negative 11. Now, what's the pattern going on? To get from my previous term to the next, so to get from negative 11 to negative 6, you're going to have to add 5. To get from negative 6 to negative 1, you add another 5. Because you can add the same number each time, this is arithmetic, and you're going to have the previous term plus 5. You could also write 5 plus a sub n minus 1, because addition is commutative. So keep in mind that a sequence can be geometric or arithmetic. That just describes the type of sequence. And then you want the format in which you're going to write the formula. It can be an explicit formula, which is on your reference sheet, to figure out how to find the nth term, or it can be a recursive formula based on the previous term to find the next. The thing about recursive formulas is that they are not good for finding future terms, such as like finding the 100th term. If you wanted to find the 100th term of example 3, right? In order to find a sub 100, you would need the previous term, which is a sub 99 plus 5. Well, in order to find the 99th term, you would need the 98th term plus 5. In order to find the 98th term, you need the 97th term. Do you see where I'm going with this? You need the previous term to get the next. So with the recursive formula, and before you got to a sub 100, the 100th term, you would need to know all the terms from 1 to 99. And that's a pain in the butt. It's going to take a very long time to figure it out. So that's a case where you would use explicit instead. But with the recursive formula, it's pretty easy to see your pattern, right? Like example 2, I can see right here, my pattern's multiplying by 2. Example 3, I can see my pattern's adding by 5. It's very a basic setup to figure out what's going on. And that's all for this video.